In this lesson, we're going to study the inverse of a function. To do this, we want to understand inverse functions. We want to also look at how we can create inverse functions and determine if two functions are inverses of one another. So if I have a function f of x, the inverse is usually represented as f to the power of -1. That's how you identify that it's an inverse of x. And if the way it works is, if I had, for example, y equal to f of x, and I have a point A such that you have 1 and 3 as the points that satisfy this function, then for the inverse of this function, f inverse of x, I'm going to have, let's call this a prime for the inverse, is going to be 3, 1. What that means is that the domain of your function becomes the range of the inverse. The range of your function becomes the domain of the inverse. And the function has an inverse if it is one-to-one, if it's a one-to-one function. So that means if I draw a horizontal line, if I have a function, for example, that looks like this, if I draw a horizontal line, it must intersect the graph at only one point. So that's what it means for you to have a one-to-one relationship on the function. So to find the inverse of a function, the first thing you want to do is to write out the function. And so y equal to f of x, whatever that is. So let's give an example. Y equal to x plus 1. The next step, switch the x and the y. So this becomes x equal to y plus 1. And then we solve for y. So I subtract 1 here, subtract 1 here. X minus 1 equal to y. So f inverse of x is going to be x minus 1. Now let's apply this to a few examples. So f of x equal to 3x minus 1. So y is equal to 3x minus 1. So we're going to switch x and y. So x is equal to 3y minus 1. We're going to add 1 here, add 1 here. So x plus 1 equal to 3y. Now we divide by 3, divide by 3. So y is equal to x plus 1 over 3. So now we have f inverse of x is equal to x plus 1 over 3. Another example here, y equal to x squared plus 4. We switch the x and y now. So x equal to y squared plus 4. And we solve for y. Subtract 4 from here, subtract 4 from here. X minus 4 equal to y squared. So the next step we want to take is to find the value of y. So we take a square root here, take a square root here. And so what we have here is y is equal to x minus 4 is the square root of x minus 4. And we want to be careful here because we want to indicate that if x is greater than or equal to 4, because square roots cannot be negative, so anything less than 4 will make this negative, so we pay attention to that. Okay, for this one, y is equal to x cubed minus 8. We swap the x and y. X equal to y cubed minus 8. And so we're going to solve for y. We add 8 over here because we need to add 8 over here. So x plus 8 is equal to y cubed. And now we want to find the value of y. So we find the third root of both sides. So we now have third root of x plus 8 is equal to y. So f inverse of x is the third root of x plus 8. Now let's go ahead with this one. Y equal to square root of x plus 1. Now we're going to swap x and y. So x is equal to square root of y plus 1. We're going to have to square both sides to get rid of the square root sign. So x squared equal to y plus 1. We subtract 1 here, subtract 1 here. So x squared minus 1 equal to y. So therefore, f inverse of x is equal to x squared minus 1. Now, if we want to find out if two functions are inverses of one another, we just compose them on one another. And when we compose, we should get x as a result. So GOF of x is equal to x, or FOG of x is equal to x. Now let's apply that in this example. So f of x is 2x minus 5. G of x is half x plus 5 over 2. So let's start with FOG of x. So that's going to be f of g of x. So f of 1/2 x plus 5 over 2. Okay, so this is equal to 2 multiplied by 1/2 x plus 5 over 2, and then minus 5. So this is going to give us x plus 5 minus 5, which is equal to x. Now, let's take an attempt at GOF of x, which is g of f of x, which is g of 2x minus 5. So this is going to give us 1/2 of 2x minus 5 plus 5 over 2. So this is going to give us 1/2 times 1/2 multiplied by 2x. That gives you x. And then 1/2 multiplied by -5 is -5 over 2 plus 5 over 2. So this gives you x. So now we have f of x is equal to -2 over x minus 5, and g of x is 5x minus 2 over x. And we want to find out if they are inverses. So let's start with FOG of x, which is f of 5x minus 2 over x, which is going to be -2 over 5x minus 2 over x minus 5. So let's deal with the denominator first and simplify that. So 5x minus 2 over x minus 5 over 1 is going to give us 5x minus 2 over x minus 5x over x. So this is going to give us, let's write it together, 5x minus 2 minus 5x over x. This is going to give us -2 over x. So this now becomes negative 2 over negative 2 over x, which is negative 2 times x over negative 2. This crosses out, so we now have x. So these are inverses of one another. Let's try GOF of x, which is going to be g of negative 2 over x minus 5, which is going to be 5 of negative 2 over x minus 5 minus 2 over negative 2 over x minus 5. Now let's simplify. This is going to be negative 10 over x minus 5 minus 2 over 1 divided by negative 2 over x minus 5. Let's simplify the numerator. So we have negative 10 over x minus 5 minus 2 over 1, which is going to be negative 10 minus 2x minus 5 over x minus 5. So this is negative 10 minus 2x minus 10 over x minus 5. So this is minus 2x over x minus 5. So now that is what the numerator becomes. So we have minus 2x over x minus 5 divided by minus 2 over x minus 5. So this is going to give us minus 2x over x minus 5 times x minus 5 over minus 2. Cross this out, cross this out. So we have x. That's proof that they are inverses of one another. Now we have f of x equal to x plus 3, g of x equal to 2x minus 3. FOG of x is going to be f of 2x minus 3. So this is going to give us 2x minus 3 plus 3, which is going to give us 2x. So this is not, they are not inverses. Let's try GOF of x. GOF of x is g of x plus 3, which is going to be 2 multiplied by x plus 3 minus 3, which is 2x plus 6 minus 3, which is going to be 2x plus 3. So this is proof that these two functions are not inverses of one another.